Three, two, one.
Assalamualaikum and hi to everyone that watch my video. My name is ASMALYANA binti KAMARUDDIN, and in this video I'm going to present my final project entitled to study the influence of empathy fruit bunch EFB fiber on the mechanical properties of cement board used in paneling. The use of supervisor empathy fruit bunch EFB fiber in organic composite has been developed in order to displace the present material, which is wood fiber. In this study, the ratio of fiber used were 0%, 15%, 17%, 20%, and 20%. This research focused on the effect of using different ratio on the mechanical strength properties of cement board and to determine the optimum ratio. A test sample were performed for thickness swelling, water absorption, density, modulus of rupture, and modulus of elasticity. The result of the test indicate that among all cement board produced using the above ratio that contain fiber, none of that satisfy the British standard for MOR and MOE, but only 0% of fiber that satisfy the both tests. For water absorption, it also not achieved the standard. However, for thickness swelling and density obtained from the test for the ratio that contain fiber achieved the standard. The study had identified that the optimal ratio is 15% to produce the cement board by using empathy fruit bunch EFB. For introduction, Malaysia is one of the main producers of the oil palm. The use of waste material for construction material has become increasingly prevalent in the building industry. Natural fiber composites are very cost-effective, low energy consumption material. They are both environment conscious and long-lasting. According to the finding, the combination between EFB fiber and cement will increase the efficiency of biocomposite material. EFB is a type of composite that is naturally composed of cellulose. Natural fiber can be used as a binder for EFB products since it contains no residual oil. For problem statement, there are three. Number one, the biggest concern which fabricating organic fiber cement board is cement and fiber incompatibility. Based on the research, there is a compatibility problem involving cement and fiber caused by the presence of hemicellulase, starch, sugar, tannin, and lignin, both of which tends to hinder cement hydrating considerably. Number two, researchers are also looking at a new natural form of lignocellulose fabric to start replacing the commonly existing fiber in the building industry. And the last one is palm oil residual abundance has been raised from 1 year to 2 years. According to the previous study, Malaysia fresh fruit bunch EFB production increased to 99.85 million tons in 2011 from 37.38 million tons of the year before. As the result, the growth of the empathy fruit bunch contribute approximately 23.8% tons of the output of the fresh fruit bunch. For literature, it based on the previous journal. According to Abbas 2018, he said that increases dimensional stability of EFB fiber cement board was achieved by the bulking impact of the additional fiber. In general, the higher the value of water absorption, the greater the value of thickness swelling. Then, also from the Abbas 2018, based on the research, the value of MOR normally decrease as the amount of EFB fiber increase. The MOR number specifies the maximum load that may be exerted on the board surface. The third one is about MOE, which is a modulus of elasticity, also from the Abbas 2018. He said that increasing the amount of EFB fiber lowers the MOE values in general. Material with the high MOE value is strong, whereas the low MOE value indicate that it may be bent easily. And the last one is about the relationship about MOE and density. Based on Ishaq 2002, he noted that the MOE values increases as density rise. Density and MOE has a tight line, which indicate that the denser a board is, the more MOE it creates. Then methodology. For material preparation, there are 3 steps. First, EFB will cut manually using scissors into the required size of length for the mixers, which is 0.5 cm to 1.0 cm. Number 2, the fiber will immerse in water and sodium bicarbonate to make sure that they are clean enough to be used. Number 3, the fiber will then hand washes and oven dry to reduce the moisture content. There are a few steps to fabricate the fiber cement board. First, mixing process. The 3 materials, which is EFB fiber, cement, and water, are mixed together before being poured in the mold. Number 2, forming process. All the mixed substance was pouring into a wooden mold, which of the measure 210 mm times 210 mm. Then, stretch and flatten the mixture by hand. Number 3, curing process. The sample was then dried at the room temperature for about 28 days. And the last one is the cutting process. The sample will cut into desired dimension. In this study, I have been done 5 testing, which is modulus of fracture, modulus of elasticity, thickness swelling, water absorption, and density. For the result, this is the result that I obtained for the testing for the density, MOR, MOE, thickness swelling, and water absorption. Let's go through one by one. Firstly, with the density. As we can see at the graph for density, the mixture 0% of fiber ratio at a higher cement content resulted in higher value of density compared to others ratio. The density of the board achieved from this investigation for 15%, 17%, 20%, and 20% is roughly in line with the goal density of less than 1000, which is based on the British standard. However, the density of 0% ratio is higher than intended. MOR, as we can see in the graph, it can be observed that the cement board with 0% of fiber has the higher value of MOR. The sample that achieved MOR requirement was the ratio 0% of fiber, with the value 10.05. The others ratio, which is 15%, 17%, 20%, and 23%, did not achieve the standard for cement board to be used as the structure in construction. The standard requirement for MOR is 9. Then for the MOE, the optimum MOE ratio is 0%. The MOE value for the 23% of ratio is extremely low, while the maximum value is for the ratio of 0%. However, the fiber ratio 70% has the highest cement content but lower MOE value than 20%. As we all know, fiber add a reinforcement in cement board to boost strength, but cement board with a fiber ratio of 70% has a high cement content that is less than the value of fiber. So, the study has shown that the criteria in MOE achieved the BS requirement for fiber with ratio 0%, while the others ratio did not achieve. And for the thickness swelling, based on the graph, it shows that the thickness swelling of fiber ratio of 23% has a higher thickness swelling than another sample. The second higher was the ratio 20%. The sample which has 0% of fiber was the lower thickness swelling, which is 0.24%. It can be observed that the ratio 23% contain high fiber content than the others ratio. The thickness swelling for 50%, 17%, 20%, and 23% as shown in the graph above meets the criteria. This one is for water absorption. As we can see in the graph, the optimum value of water absorption is 148.36%, which occur at 23 ratio of fiber. For 20% and 70% of fiber ratio, the water absorption values were 132.68% and 94.46% respectively. The water absorption of EFB fiber cement board increased when the fiber content was increased. This is due to the presence of dry fiber and wood inside the cement board, which have the susceptibility to absorb water when submerged. So, in conclusion, all the tests give a different effect on mechanical strength properties of EFB fiber cement board. This might be happen due to improper mixing process, and the size of fiber used in this study was not required, which is 0.5 cm to 1.0 cm. All of this happened because lack of machine at our laboratory. So we need to do all the process manually. As example, the EFB fiber were cut manually using scissors into required size of the length of the mixers. From this study, it has been identified that the optimal fiber ratio is 15% to produce the cement board by using empty fruit bunch. This is all the references that I use in my presentation. So that's all from me. Thank you.